So in this session, let us observe what are the images that we have in our dataset. So this dataset contains three folders, that is three classes. So I am taking one of the classes and visualizing the images that it contains. So you can see that I have taken potato early blight folder from the plant disease folder, which is having 12 images for visualization. So here you can see that plot.imshow function is used to visualize these images, which is under matplotlib. So if I run this commands, so after running this command, you can see these images which are of size 256 by 256. Now let's move forward and convert our images into array. So after visualizing, we will create these images into NumPy array. It is required because we will need to normalize our dataset after this. So after creating the function, let us call the function and convert all these images into NumPy array. Here you can see that I have been using the path plant images project bank, which contains three other folders. And the label names of those folders are corn common rust, potato early blight, and tomato bacterial spot. So we will be working on these three plant diseases. Let's run these commands and convert all these images into NumPy array. It will take some time because we have around 900 images in that. So here you can see that the command has run. So all the images have been converted into NumPy array. The next step is to visualize the number of images and the different classes. This is important because we need to see that the data set is balanced or not. So when I run this, I am getting three classes with 300 images in each class. It implies that the dataset is completely balanced. Now let's observe the shape of the image. Using image list, that is the first image, and the shape of the image is 256 by 256 by 3. We have already visualized that in above cells also it is of a 3 channel, that is RGB, because it is a colored image. Next, let's check the total number of images, which is length of the labels list. So here we can see that it is 900. The next step is to test, train and split the dataset. So we are using sklearn test, train, split on dataset. You can see that I have taken the test size as 0.2 so that my data is divided into 80% as training and 20% as testing. Let's run this command and divide the data. After this, we will normalize the data set of our images. For this, we are dividing it by 225 and we are also reshaping it. So let's run this command and perform this pre-processing of the images. Next, we will convert the data into categorical, that is one hot encoding. So one hot encoding is required because if we don't do one hot encoding for the target feature, the machine will try to prioritize it. So we'll perform this one hot encoding using two categorical function, which is already defined under Keras. So let's run this command and do one hot encoding on the data set.